Module 3. Improving student fluency with addition, subtraction, multiplication, and division. Improving student fluency with addition, subtraction, multiplication, and division is a fundamental aspect of elementary mathematics education. Fluency in these operations involves not just the ability to recall basic facts quickly, but also understanding the underlying principles and being able to apply them in various contexts. One crucial aspect of developing this fluency is the interplay between place value understanding and computational strategies for addition and subtraction. Place value is the cornerstone of our number system, and a deep understanding of it is essential for performing operations efficiently and accurately. For instance, when adding numbers like 456 and 378, understanding that each digit represents a different place value, hundreds, tens, ones, allows students to align and add the numbers correctly, starting from the ones place, carrying over when sums exceed 10, and continuing through the tens and hundreds places. This understanding helps students avoid common mistakes and fosters a more intuitive grasp of how numbers work. Similarly, subtraction benefits from a strong grasp of place value. When subtracting, say, 732 from 1,845, students need to understand borrowing, which is essentially redistributing place values. Without this foundational knowledge, students might struggle with more complex subtractions, leading to errors and confusion. By consistently reinforcing place value, educators can help students develop a robust framework for these operations. Understanding place value also supports learning a variety of computational strategies in multiplication. For example, multiplying 23 by 45 can be broken down using the distributive property, 20 plus 3 times 40 plus 5. This can be expanded to 20 times 40, 20 times 5, 3 times 40, and 3 times 5, and then summed to get the final result. This strategy not only simplifies the multiplication process, but also highlights the connections between place value and operations, reinforcing students' overall number sense. Moreover, teaching students to connect number and algebraic thinking through properties of operations builds both number sense and procedural fluency. Properties, such as the commutative property, 4 plus 5 equals 5 plus 4, associative property, parentheses 2 plus 3 plus 4 equals 2 plus parentheses 3 plus 4, and distributive property, A times B plus C equals A times B plus A times C allows students to manipulate and understand numbers in flexible ways. This flexibility is crucial for solving problems efficiently and understanding more complex mathematical concepts later on. When addressing addition and subtraction, one must consider various problem structures. For example, the join result unknown structure is seen in problems like Marianne had 3 library books before she checked out 2 more. How many did she have altogether? Here, students must combine quantities to find the total. This type of problem helps students practice addition in a context that makes sense and encourages them to think about how quantities combine in real life. In contrast, the separate start unknown structure, as in Marianne had some nonfiction books and 2 fiction, she now has 8 books. How many did she begin with? Requires students to think backwards to determine the initial quantity. This type of problem fosters an understanding of subtraction as the inverse of addition, reinforcing the relationship between these operations. Another common structure is the compare difference unknown, such as Marianne had 9 library books and Jim had 4. How many more did Marianne have than Jim? This problem type helps students develop skills in comparison and understanding differences, which are essential for both subtraction and more advanced concepts like ratio and proportion. Teaching multiplication and division involves addressing several key elements. One important aspect is understanding what to do with remainders. For example, when dividing 15 by 4, students should understand that the result is 3 with a remainder of 3. This knowledge is crucial for real-world applications, where division often doesn't result in whole numbers. Additionally, symbolism as a way to record thinking, using physical models, drawings, and equations helps students visualize and conceptualize these operations. The multiplicative structure of a number aids in acquiring skills like reading large numbers and generalizing the structure of the number system. For instance, knowing that 10 in any position means a single thing in the next bigger place, like 10 tens make 100, is fundamental for understanding large numbers and performing multiplication and division. Guiding students to conceptualize numbers with 4 or more digits involves generalizing ideas about place value. For example, students should understand that 10 in any one position results in one single thing in the next bigger place, as with 10 hundreds making 1,000. Using models of unit cubes and providing hands-on, real-life examples can make these abstract concepts more concrete and understandable. Patterns and relationships on a hundreds chart are also valuable tools. For instance, counting by tens going down the far right-hand column, or starting at 11 and moving diagonally to find the same number in the ones and tens place helps students recognize numerical patterns and relationships. In a column, the first number, tens digit, increases by ones as you move down, reinforcing place value and the structure of the number system. Different methods used for computation, such as standard algorithms, student-invented strategies, and computational estimation, each have their benefits. Invented strategies, for instance, help reduce the amount of reteaching needed, develop stronger number sense, and are frequently more efficient than standard algorithms. Examples of invented strategies include the jump strategy, split strategy, and takeaway strategy. These strategies allow students to approach problems in ways that make sense to them, fostering deeper understanding and flexibility in thinking. An open number line can be used effectively for thinking about addition and subtraction because it eliminates confusion with hash marks and spaces, is less prone to computational errors, and helps model student thinking. By placing numbers on a line, students can visually see the distances between them, making addition and subtraction more intuitive. Computational estimation is another crucial skill, involving the use of language such as about, close, and just about. Focusing on flexible methods and accepting a range of estimates helps students develop a sense of approximation, which is valuable in many real-world situations. Estimation encourages students to think critically about the reasonableness of their answers and to develop number sense. There are clear differences between invented strategies and standard algorithms. Invented strategies offer a range of flexible options, are often left-handed rather than right-handed, and are number-oriented rather than digit-oriented. These characteristics make invented strategies more adaptable to different problems and more intuitive for students. The Common Core State Standards emphasize that students should learn a variety of strategies based on place value, properties of operations, and should be taught prior to the standard algorithm. This approach ensures that students have a solid understanding of the principles behind the operations before learning the traditional methods. For instance, a student multiplying 58 times 6 by adding 58 plus 58 to get 116, then adding another 116 to get 232, and finally adding another 116 to find the product of 348 is using a complete number strategy. This method breaks the problem into manageable parts and leverages addition skills to solve a multiplication problem, demonstrating an understanding of the relationship between these operations. When developing the written record for multiplication computation, it is helpful to encourage students to use sheets with base 10 columns, record partial products, and combine these products on one line. This structured approach helps students keep track of their calculations and understand the intermediate steps in the multiplication process. Division can be easier for students if they are familiar with concepts like partitioning, fair sharing, and repeated subtracting. Understanding these concepts helps students visualize and conceptualize division, making it more accessible. For example, partitioning a set of objects into equal groups, or using repeated subtraction to find how many times one number fits into another, are both effective strategies for teaching division. Cluster problems are an approach to developing the missing factor strategy and capitalize on the inverse relationship between multiplication and division. For example, solving 381 divided by 72 can be approached by recognizing that 10 times 72 is 720, 5 times 70 is 350, and 4 times 72 is 288. These clusters help students see the relationship between the numbers and find the solution more efficiently. In summary, improving student fluency with addition, subtraction, multiplication, and division involves a comprehensive approach that integrates place value understanding, computational strategies, and conceptual connections. By addressing these elements through various problem structures, hands-on activities, and flexible strategies, educators can help students develop a deep, robust understanding of these fundamental operations. This foundation is essential for their continued success in mathematics and their ability to apply these skills in real-world situations.